On August 14th, 2024, at 4:22 a.m. Coordinated Universal Time, NASA astronaut Harper Calloway screamed into the void. Not the controlled, measured voice you'd expect from a 12-year veteran of orbital operations. Not the calm radio discipline drilled into former Navy test pilots over thousands of flight hours. A scream. Raw. Immediate. The kind that bypasses training and comes from somewhere deeper than procedure. 3 words transmitted from 254 miles above Earth's surface, broadcast on EVA comm channel Alpha 7, before the feed cut to absolute silence. They're here. Harper Calloway was not supposed to be alone outside the International Space Station that morning. The scheduled extravehicular activity for Expedition 71 called for a 2-person team to replace a failed thermal control radiator on the P6 truss assembly, the port-side solar array structure extending like a metallic wing from the station's central corridor. But when Commander Yuki Tanaka developed inner ear complications 40 minutes before suited operations, mission protocols required postponement. Except the radiator had been running at 63% efficiency for 11 days, and thermal margins on the ammonia cooling loop were approaching critical thresholds. Harper, with 3 previous EVAs totaling 19 hours outside pressurized environments, volunteered to proceed solo. Houston approved. Standard risk assessment. Standard protocols. Nothing about August 14th suggested it would be anything but a routine maintenance operation in the vacuum. For 2 hours and 47 minutes, Harper's voice was a constant presence in the headsets at Mission Control in Houston, at the European Space Agency's Coordination Center in Darmstadt, and at Roscosmos Mission Control in Korolev, calling out tool transfers, confirming torque readings on thermal interface bolts, describing ammonia pressure levels in mechanical detail. The voice of someone who had spent 4,312 hours in space across 3 missions, someone who understood that in the vacuum, precision of language equals precision of survival. Then, at exactly 4:22 a.m. UTC, during what should have been a straightforward electrical connection verification, Harper's biotelemetry spiked. Heart rate jumped from 68 beats per minute to 112. Respiration climbed. And then those 3 words, followed by 18 minutes of nothing. Not static. Not garbled transmission. Not the hiss of solar interference or the crackle of ionospheric disturbance. Silence. Complete and absolute. The kind of silence that doesn't happen with the redundant quadruple backup communication systems built into EVA suits, systems designed to function through solar storms, through equipment failures, through scenarios NASA engineers spent decades imagining. Harper's suit telemetry continued streaming. Life support nominal. Power levels stable. Oxygen consumption slightly elevated, but within normal parameters. The suit was functioning. The astronaut inside it simply wasn't speaking. And mission control, bound by protocols written in blood and lessons learned from Columbia and Challenger, waited. Because you don't interrupt an astronaut's concentration during critical operations. You wait. You monitor. You trust their training. 18 minutes later, Harper's voice returned. Calm. Measured. The controlled radio discipline of a 12-year veteran. Requesting permission to complete the radiator installation and return to the airlock. No explanation for the silence. No reference to the 3 words that had preceded it. Houston, caught between relief and profound unease, cleared Harper to proceed. 41 minutes later, Harper cycled through the Quest airlock, desuited with methodical efficiency, and filed a routine EVA report that made no mention of anything unusual. The report was 3 pages, It described torque specifications, thermal readings, and installation sequences. It read exactly like the hundreds of EVA reports filed before it. But Maya Torres knew something was wrong. She'd been monitoring that EVA from her workstation in the communications branch at Johnson Space Center, 8 years into a career that started with a doctorate in aerospace engineering from MIT and evolved into something else entirely, something that lived in the spaces between official telemetry and what actually happened up there in the orbital night. Maya had access to systems most NASA personnel never saw, the layered archives of mission data that captured everything, every voltage fluctuation, every sensor reading, every byte of transmitted information. And when she pulled the full telemetry package from Harper's EVA, she found something that shouldn't exist. An encrypted audio file buried in the metadata, carrying a classification code she'd never seen applied to routine maintenance operations. The file was locked. Department of Defense protocols. The kind of encryption that required authorization levels Maya didn't have and couldn't request without explaining why she was looking. But she knew what it meant. Standard EVA communications weren't encrypted. They were broadcast openly, available to anyone with the right receiver. Amateur radio operators tracked ISS transmissions as a hobby. School children listened to astronaut conversations for science projects. Transparency was policy. Encryption was the opposite of policy. Encryption meant something had been said that wasn't supposed to be heard. And 18 minutes of silence meant someone had decided, very quickly, that whatever Harper had seen up there needed to disappear. Maya spent the next 72 hours doing what she'd learned to do in 8 years of working in the gaps between official narratives and actual events. She looked for patterns. Not in the present, where active monitoring and real-time classification could catch her digital footprints, but in the archived data, the closed mission files, the telemetry packages from EVAs already completed and filed and forgotten by everyone except the automated systems that stored everything forever. She built a search algorithm that didn't look for anomalies directly, that would trigger security protocols, but instead searched for commonalities in metadata structures, for encryption tags applied to communication files, for gaps in continuous data streams that matched the duration and signature of what had happened to Harper. And what she found, cross-referenced against 14 months of ISS operations and 3 previous expedition cycles, made her pull double shifts in her apartment, door locked, using her personal laptop instead of NASA systems, because this wasn't the kind of pattern you explored through official channels. 7 EVAs, 7 separate extravehicular activities spread across 14 months. Different crew members, different mission objectives, different positions on the station's exterior. Expedition 68, 69, 70, and now 71. Communication interruptions ranging from 11 minutes to 23 minutes. Every single one officially classified as solar interference or temporary equipment malfunction. Every single one followed by flawless EVA completion and routine reports that mentioned nothing unusual. And every single one carrying the same encrypted audio file in the metadata, the same Department of Defense classification code, the same digital signature of information that had been captured, locked, and buried. Maya pulled the solar activity data from NOAA's Space Weather Prediction Center for each date, timestamps precise to the minute, solar flux indices, X-ray emissions, geomagnetic storm classifications. The official explanation for communication disruption required elevated solar activity, radiation bursts strong enough to overwhelm suit communication systems despite their hardening against exactly that kind of interference. But the data showed something else entirely. On 6 of the 7 dates, solar activity was below baseline. quiet sun conditions, the kind of cosmic silence that made communication clearer, not disrupted. On the seventh date, there had been a minor C-class solar flare, the kind that happened dozens of times per year and never affected orbital communications. The official explanation was impossible, which meant someone had needed an explanation that sounded plausible enough that nobody would look deeper, and solar interference was the universal excuse, the catch-all answer that required specialized knowledge to verify and that most people simply accepted. Maya knew she needed an outside perspective, someone who'd been up there, who'd understand what these patterns meant beyond the data. Who could tell her if 18 minutes of silence during an EVA was the kind of thing that happened for reasons the telemetry wouldn't capture? She thought about the crew rosters, about the astronauts and cosmonauts who'd served with Harper on previous missions, and one name surfaced with absolute clarity: Dmitry Volkov. Russian cosmonaut, now retired, 61 years old, 3 long-duration missions totaling 547 days in orbit, and more importantly, Harper's crewmate during Expedition 64, 2 years ago. Maya had met Dmitry twice, briefly, during crew integration training sessions where NASA and Roscosmos personnel overlapped in preparation for joint operations. He'd impressed her as the kind of professional who saw things other people missed and had the good sense to stay quiet about them until the right moment. She found his contact information through unofficial channels, the network of space program personnel who stayed connected across agencies and borders because the experience of looking at Earth from orbit created bonds that transcended geopolitics. The call to Moscow went through at 11:30 p.m. Houston time, 7:30 a.m. in Russia, and Dmitry answered on the second ring. She didn't explain everything. She couldn't. Not over international phone lines that she had to assume were monitored by multiple intelligence agencies. But she asked about Harper, about Expedition 64, about whether anything unusual had happened during their EVAs together. Dmitry's pause lasted long enough that Maya thought the connection had dropped. Then his voice came back, quieter, more careful. There was one event. November of 2022. Joint EVA, Harper and myself, replacing micrometeorite shielding on the Zarya module. Harper was anchored to the nadir-facing workstation. I was 30 feet away on the transfer boom. We'd been outside for 90 minutes. Communication continuous, normal operations. Then Harper stopped moving. Completely still. For 40 seconds, maybe more, just staring into space. Not at Earth. Not at the station. Out into the black, toward the direction we call the RAM vector, the direction of orbital velocity, where there's nothing but empty space and distant stars. Dmitry paused again, and Maya heard something in the background, maybe a door closing, maybe him moving to a more private location. I called his name 3 times before he responded. When he did, he asked me what I was talking about. He had no memory of stopping, no memory of those 40 seconds. I checked his suit telemetry later, privately. His heart rate had jumped. His oxygen consumption had spiked. But his position logs showed he was stationary, locked to the safety tether. I never filed a report. Harper was a good astronaut. Good people. I thought maybe it was fatigue or a momentary disorientation. But I remembered it, and I've thought about it many times since. Maya asked the question she already knew would have no good answer. Did you see anything out there? In the direction he was looking? Dmitry's response was immediate. No, but that doesn't mean there was nothing there. Space is very large, Maya, and our eyes are very small. She thanked him and ended the call, but something he'd said stayed with her, circling in her mind like debris in decaying orbit. Harper had no memory. just like Harper had filed a routine report after August 14th with no mention of screaming 3 words into the void. Memory suppression could be psychological, a trauma response, the mind protecting itself from something it couldn't process. Or it could be something else, something deliberate. Maya went back to Harper's August EVA telemetry, this time looking beyond the communication data, diving into the suit's inertial measurement unit, the accelerometers and gyroscopes that tracked every movement in 3-dimensional space. And there, buried in 18 minutes of data that should have shown Harper stationary at the P6 truss workstation, she found an impossibility that made her pull back from her laptop and sit in darkness for a long time, trying to understand what she was seeing. The IMU had recorded acceleration, 0.7 g-force, sustained for 11 seconds, in a vector perpendicular to the station's orbital path. But Harper's tether logs showed him anchored, locked to the station with safety cables rated for 1,500 pounds of force. The only way to record that kind of acceleration in vacuum was through active propulsion, the suit's safer jetpack firing to generate thrust. But the safer logs showed 0 activation. No propellant use, no thrust events. Harper had accelerated without propulsion while anchored to a fixed point. That wasn't equipment malfunction. That wasn't possible under any known physics. Something had pulled him. Something had exerted 7/10 the force of Earth's gravity on a human body in the vacuum of space, while NASA's tracking systems registered nothing, while radar showed empty space, while the official record stated that 18 minutes passed in routine silence. And whatever it was, Harper didn't remember it happening, or couldn't, or had been made to forget. Maya needed access to files she couldn't request through official channels, which meant reaching outside NASA's information architecture entirely, into the parallel world of Department of Defense systems, where space operations intersected with national security classifications that predated the Space Shuttle program. She thought of Jordan Hayes, someone she'd known since their overlapping years at MIT, back when they were both convinced that engineering problems had engineering solutions and that transparency was a feature, not a vulnerability. Jordan had gone a different direction after graduation, into information security analysis for the DoD, working in the gaps between military space operations and civilian programs, managing the data flows that kept certain things visible and other things very carefully hidden. They hadn't spoken in 14 months, not since a conference in Denver where they'd shared coffee and avoided talking about the increasing classification of space-related intelligence, the way more and more orbital data was disappearing behind security walls that didn't seem proportional to the stated threats. Maya sent an encrypted message through a private channel they'd established years ago, back when encryption felt like paranoia rather than necessity. The message was brief. Need to know about comm blackouts during EVA ops, seeing pattern that doesn't match official explanations. Can you look without triggering alerts? Jordan's response came 6 hours later. Meet me in San Antonio, Alamo Plaza. 2 days. Come alone. The meeting happened on a Thursday afternoon, tourist crowds providing cover, the kind of public anonymity that made surveillance difficult without being obvious about it. Jordan looked older than 14 months should account for, the kind of aging that came from seeing things you couldn't unsee and being required to act like you hadn't. They walked the perimeter of the plaza twice before Jordan spoke. I found something, but before I show you, you need to understand that what you're asking about isn't new. It's not recent, and it's not accidental. Jordan handed Maya a tablet, screen showing a scanned document, official letterhead from 1998, a joint memorandum from NASA administration and Department of Defense Space Command. The header read, Protocol Nightfall: Procedures for Unidentified Proximity Events During Crewed Orbital Operations. D. Maya read it standing there in sunlight while tourists took photos of the mission's facade, and what she read recontextualized everything she thought she understood about how space agencies handled the unknown. The protocol was specific, detailed, the kind of document that gets written after something has already happened enough times to require standardized response. Section 3 outlined communication procedures: immediate termination of public broadcast feeds upon detection of unidentified objects within 5 kilometers of crewed vehicles, transfer to encrypted military channels, classification of all telemetry data under national security statutes. Section 7 detailed crew psychological protocols: mandatory debriefing by cleared personnel within 12 hours of event conclusion, evaluation for information, compartmentalization necessity, administration of recommended pharmaceutical intervention if deemed essential for operational security. The language was bureaucratic, carefully neutral, but the implications were clear. This wasn't a contingency plan for theoretical events. This was standard operating procedure for something that happened regularly enough to require a protocol manual. Maya looked up from the tablet. How many times has this been activated? Jordan's expression didn't change. The document doesn't include implementation logs. Those would be classified higher than my access level. But I can tell you that the protocol has been updated 4 times since 1998. The most recent revision was 6 months ago. You don't keep updating procedures for theoretical scenarios. Maya felt something shift in her understanding, the way orbital mechanics students felt when they finally grasped that there's no up or down in space, that all reference frames are relative, that everything they thought they knew about direction was earthbound thinking. Harper was debriefed for 11 hours after that EVA. I saw the medical schedule. They listed it as routine psychological evaluation. Jordan nodded slowly. Section 7, Paragraph 4, Standard Implementation. And Maya, there's something else you need to know. Harper isn't the first astronaut to undergo extended evaluation after an EVA communication blackout. In the last 3 years, 7 crew members have been cycled through what the protocol calls Information Compartmentalization Assessment. 5 were cleared and returned to flight status, with no public record of the events. 2 were retired on medical grounds that their pre-mission health records don't support. The pattern is consistent. The response is systematic. This isn't reactive. It's managed. Maya asked the question that had been building since she first saw the encrypted file in Harper's telemetry. What are they seeing up there? Jordan looked away, across the plaza, toward the mission building where men had died, defending something they believed mattered. I don't know. But I can tell you what the protocol assumes they're seeing. Something that requires immediate information suppression. Something that poses no immediate physical threat, but represents significant national security implications. And something that happens frequently enough to justify maintaining a permanent, updated response framework across multiple space agencies and governments. NASA, Roscosmos, ESA, CNSA. They all have equivalent protocols. I've seen references to coordination agreements. Whatever this is, it's not just an American secret. Maya handed back the tablet, but Jordan shook his head. Keep it, encrypted. The document is already leaked, technically. What matters is what you do with the information. But you should know something else. There's verification of Harper's EVA that exists outside NASA's control. Amateur radio operators monitor ISS communications. It's public, unencrypted. Or it's supposed to be. But there's a ham operator in Australia retired aerospace engineer named Colin Wright, who recorded the 4.7 seconds before the communication blackout on August 14th. He posted about it on a radio enthusiast forum, asking if anyone else had captured the anomaly. The post was deleted within 8 hours, but I found a cached copy. And Maya, the recording has something NASA's official feed doesn't have. After Harper says, "They're here," there's another voice. It's not Harper. It's not anyone on the ISS crew roster. The voice says, "Confirming visual contact." Then the feed cuts. Jordan made one more contact before disappearing back into the classified world of DoD information architecture. A message delivered through the same encrypted channel 3 days after San Antonio, containing a single file attachment and no explanatory text. The file was a video segment, 9 seconds of helmet camera footage, timestamp burned into the lower right corner. August 14th, 2024, 4:21 a.m. and 37 seconds UTC, 48 seconds before Harper's transmission cut to silence. The video quality was degraded, compressed multiple times, the kind of artifacting that suggested the file had been copied from a system it wasn't supposed to leave, then copied again, laundered through enough transfers to obscure its origin. But the content was clear enough. Harper's perspective, looking across the station's exterior structure toward the cupola observation module, the 7-window dome that gave crews 360-degree views of Earth and space, the component that had produced more photographs of our planet than any other human-made structure in history. Except in the video, in the reflection visible on Harper's visor, polycarbonate curved surface catching light like a mirror in the void, the cupola's windows weren't showing Earth. They weren't showing the black of space or the silver-white of station modules or the gold shimmer of solar arrays. They were showing something solid. Maya watched the 9 seconds 17 times, frame by frame, trying to understand what she was seeing. The reflection was distorted by the visor's curvature, warped by the fish-eye effect of convex surfaces, but the geometry was unmistakable. A surface. Textured in ways that didn't match any material she'd seen in 12 years of aerospace engineering, patterns that suggested either massive scale observed from distance or fine detail observed from proximity. Impossible to determine which without reference points that the video didn't provide. The color was wrong, too. A kind of matte darkness that didn't reflect light the way metal or composite materials should, that seemed to absorb photons rather than bounce them back, creating an almost two-dimensional appearance that her brain kept trying to reject as sensor error or compression artifact. But this wasn't a sensor. This was optical reflection, light traveling from source to surface, to visor, to camera. The most basic physics of observation. What the video showed was there. Or had been there. 200 meters from the International Space Station, close enough to fill 70% of the visual field from Harper's position, large enough to block the view of Earth from multiple cupola windows simultaneously, massive enough that its presence should have been impossible to miss by every tracking system humanity had pointed at near-Earth orbit. She needed verification from someone who understood optical physics better than she did. Someone who could confirm that what she was seeing in the reflection wasn't an artifact of the visor curvature or the video compression or her own desperate need to find evidence of something impossible. Maya reached out to Tessa Klein, optical systems engineer with the European Space Agency, someone she'd worked with during the development of the ISS environmental monitoring cameras, back when both of them believed that better imaging systems would help humanity understand Earth's climate systems, and that engineering could solve problems that politics couldn't. The conversation happened over secure video link, Maya sharing the 9-second clip without context, asking only if Tessa could analyze the reflection geometry and determine what, if anything, it revealed about the reflected object's actual size and distance. Tessa worked in silence for 40 minutes, running the footage through analysis software, mapping the visor curvature against known reference points in the background, calculating angular distortions and light path geometries. When she looked up from her workstation in Darmstadt, her expression carried the particular tension of someone who'd just confirmed something they'd hoped would prove false. The reflection is consistent with a physical object at approximately 180 to 220 meters distance from the camera's position. Based on the angular coverage in the reflection and accounting for visor distortion, the object's apparent size from Harper's perspective would be between 150 and 200 meters across. The surface texture analysis is inconclusive. The material properties don't match any spacecraft composite in ESA's database, or NASA's, or any commercial satellite manufacturer I can reference. The light absorption characteristics are outside normal ranges for orbital hardware. Maya, what am I looking at? Maya didn't have an answer that made sense, so she asked a different question. If an object that size was holding position 200 meters from ISS on August 14th, would NORAD's space surveillance network have tracked it? Tessa's response was immediate. Absolutely. NORAD tracks objects down to 10 centimeters at that altitude. Something 200 meters across would be flagged automatically. Collision avoidance protocols would activate. The station would maneuver if necessary. There's no scenario where an object that large goes undetected. She paused, then added quietly, unless someone decided not to detect it, or decided not to report it. Maya knew she was running out of safe options, that every inquiry she made left digital traces, that patterns of investigation eventually triggered the same protocols that had buried Harper's experience behind encryption and classification. But she also knew that Harper was the only person who could tell her what had actually happened during those 18 minutes, what had been seen, what had been experienced, what had been significant enough to activate a protocol that had existed for 26 years and crossed international boundaries. She found Harper's personal contact information through channels that would definitely be noticed if anyone was watching, and made a call she knew might end her career at NASA before the conversation concluded. The phone rang 4 times before Harper answered, voice careful, guarded, the tone of someone who'd learned that every communication could be monitored. Maya identified herself, then asked the only question that mattered. What did you see on August 14th? The silence lasted long enough that Maya thought Harper had terminated the call. Then Harper's voice came back, different than before, quieter, but somehow more present, more immediate. I remember now. I remember all of it. They took that from me for 3 weeks, the memory, made it fuzzy and distant, like a dream I couldn't quite recall. But it's coming back. Maya, they've been waiting. Watching. Not just at ISS. Everywhere we've gone. Every altitude. Every mission. They've been patient in ways we can't comprehend because we measure time in decades, and they measure it in epochs. And Maya, listen to me carefully. They know your name. They know you're asking questions. I don't know how, but during the debriefing, they asked me specifically about you, about whether we'd discussed the EVA, about whether you'd accessed the telemetry files. This isn't random. This is active monitoring. You need to stop looking. You need to... The call cut. Not disconnected, not dropped, but terminated mid-sentence with the clean precision of a deliberately severed connection. Maya tried calling back. The number was no longer in service. She checked Harper's duty status through NASA's internal systems. Medical leave, effective immediately, Transferred to extended evaluation at Edwards Air Force Base in California. Location within the facility, not specified. Expected return to active duty. Pending ongoing assessment. She pulled Harper's service record one more time, looking for anything that would explain a sudden medical transfer for someone whose pre-mission physicals had rated them in the top 5% of astronaut corps' health metrics. The record showed one new entry, added 4 hours ago, medical classification code, that Maya had to look up because she'd never seen it used for active astronauts. The code's meaning, buried in NASA's administrative documentation, was clear enough. Indefinite hold, psychological evaluation, location undisclosed for participant welfare. Harper had disappeared, not into space, into the architecture of institutional silence that Protocol Nightfall had been designed to maintain. And somewhere in that silence, Harper had confirmed what Maya had been assembling from fragments and shadows and impossible physics. Something was up there. Something had been up there for a long time, and it knew they were looking. Maya spent the next 11 days doing what people do when they know they're being monitored but can't stop searching for truth. She compiled everything into a single encrypted archive. Every piece of evidence, every impossibility, every fragment of pattern that suggested humanity's relationship with orbital space was not what the public record claimed. She worked from coffee shops and public libraries, never the same location twice, using devices that couldn't be traced back to her NASA credentials, assembling a timeline that stretched back further than Protocol Nightfall, further than the International Space Station, all the way to the beginning of human presence beyond Earth's atmosphere. The archive showed 44 documented communication events during crewed missions, incidents where transmissions were interrupted, where crew members reported phenomena that weren't included in official records, where psychological evaluations became mandatory, and classifications appeared where transparency had been policy. 44 events across 63 years, from Yuri Gagarin's first orbit in 1961 to Harper's scream in 2024. The pattern held across agencies, across decades, across geopolitical divides that had fractured humanity into competing space programs. Every incident occurred at altitudes between 320 and 450 kilometers. Every incident happened during orbital night, when spacecraft passed through Earth's shadow, when solar radiation couldn't interfere with observations, when the darkness of space became absolute, and whatever was out there could approach without the complications of reflected sunlight. The consistency suggested something Maya hadn't wanted to acknowledge until the evidence became impossible to ignore. This wasn't random. This was systematic observation from something that understood orbital mechanics, that knew when and where to appear for maximum effect and minimum public visibility, that had been patient enough to watch humanity's first steps into space and every step since. She reached out to one final source, someone outside the space agencies entirely, someone whose perspective came from theoretical physics rather than engineering pragmatism. Dr. Kenji Yamada, astrophysicist at the University of Tokyo, specialist in the Fermi paradox and the mathematical frameworks that tried to explain why humanity had never detected signs of intelligent life beyond Earth, despite the statistical probability that such life should exist in abundance. Maya sent him the timeline without names or classified details, just the pattern. 44 contact events across 63 years, clustered at specific altitudes, all during periods of orbital darkness. She asked a simple question. If an advanced civilization wanted to monitor an emerging technological species without direct interference, what would that monitoring look like? Dr. Yamada's response came through academic channels, published as a theoretical paper that never mentioned NASA or ISS or any specific incidents, but addressed the question with mathematical precision. He called it the threshold hypothesis. The idea was elegant in its simplicity. Any civilization capable of interstellar observation would recognize that the moment a species achieves sustainable orbital presence represents a fundamental transition, the point where planetary confinement ends and the possibility of expansion into the broader cosmos begins. Low Earth orbit, the region between 300 and 500 kilometers altitude, would be the logical boundary to monitor. Not the first satellite, which could be automated, not the first brief sortie into space, which could be anomalous, but sustained human presence, permanent stations, regular transit between surface and orbit. That would be the signal. That would be the moment when observation shifts from passive to active, when the watchers decide whether the watched are ready to know they're not alone. Dr. Yamada's paper proposed that such monitoring would be subtle, careful, designed to assess capability and intention without triggering panic or premature contact. Communication disruptions, visual phenomena that violated known physics just enough to be noticed by trained observers, but not enough to be undeniable to the general population. Encounters calibrated to the edge of believability, where official denial remained plausible, but those who experienced the events would carry the knowledge forward, would wonder, would question. Maya read the paper 3 times, understanding that Dr. Yamada had answered her question without ever acknowledging that the question was about real events rather than theoretical scenarios. Humanity had passed the threshold. Somewhere between Gagarin's first orbit and the permanent occupation of the International Space Station, we had demonstrated that we could sustain ourselves beyond our atmosphere, and something had noticed. But the archive had one more piece of evidence, something that arrived anonymously. No return address. A physical envelope delivered to Maya's apartment containing photographs that shouldn't exist. Apollo 11 mission images, dated July 20, 1969, never released in official NASA archives. The photos showed Neil Armstrong and Buzz Aldrin on the lunar surface, both astronauts facing upward. Same posture, same direction, the kind of coordinated attention that suggested they were observing something significant. In the corner of one photograph, captured in the reflection on Aldrin's visor, there was a shape. Dark, angular. Geometric in ways that lunar rock formations weren't geometric. The shape was impossible to resolve clearly, distorted by the visor's curve and the photograph's grain, but its presence was undeniable. Something had been there. Something had been watching the first human footsteps on another world. And 55 years later, Harper had screamed 3 words that confirmed the observation was still ongoing, still active, still silent. The question wasn't whether we were alone anymore. The evidence made that answer clear enough. The question was deeper, more unsettling in its implications. How long had they watched before we achieved orbit? Had they observed our radio transmissions, our first satellites, our nuclear tests that announced our technological adolescence to anyone monitoring electromagnetic spectrum? Or had they been here longer, watching our species climb from stone tools to rocket engines, patient in ways that civilizations think in geological time rather than election cycles? And the harder question, the one that Maya couldn't answer from telemetry data or classified protocols or theoretical papers. Why the silence? Why the careful distance? Why reveal themselves only to astronauts in the void? Only during moments that could be classified and contained? Only in ways that ensured the broader population remained unaware? Dr. Yamada's threshold hypothesis suggested an answer: assessment. Observation to determine if humanity was ready for contact. If we could handle the knowledge that we weren't unique, that the cosmos was occupied, that our significance in the universe was different than everything our religions and philosophies had assumed. And maybe, Maya thought, maybe we weren't ready. Maybe the fear and wonder and existential vertigo of knowing we were watched would fracture societies already strained by divisions that seemed impossible to bridge. Or maybe the silence meant something else. Maybe they were waiting not for us to be ready, but for us to prove something, to demonstrate that we could move beyond our planet without bringing our worst impulses with us, to show that a species capable of orbital presence could also be capable of wisdom. Harper's last words before disappearing echoed in Maya's mind. They've been waiting, not attacking, not invading, waiting. And in that waiting, in 63 years of careful observation and calibrated contact, there was something more profound than threat. There was patience. There was interest. There was the possibility that somewhere in the silence between stars, someone was hoping we'd figure out how to be worth knowing. Maya couldn't prove any of it in ways that would survive official scrutiny. The evidence was fragmentary. The witnesses were silenced or disappeared, and Protocol Nightfall ensured that whatever happened up there stayed buried under classifications that would outlive everyone currently involved. But she knew, and knowing changed everything. Every time she looked at the night sky now, she wondered about the spaces between stars, about what observed us from distances we couldn't measure, about whether the lights moving across the orbital plane were satellites and stations, or something else, something patient, something waiting to see what we'd become. Harper had screamed, "They're here." But the deeper truth, the one that made sleep difficult and wonder inescapable, was simpler and more profound. They'd always been here. We were just finally becoming aware enough to notice. And what we did with that awareness, how we responded to the knowledge that we were not alone and never had been, would determine whether the silence continued or whether, someday, the watchers would decide we were ready for the conversation that would change everything humanity thought it understood about its place in the cosmos.